Hello everybody, welcome. This video is about the syntax of decorators in Python, the purpose and some examples of practical use. And the reason of this video is that lately I wanted to, get things straight about the proper syntax for defining and using decorators, and I made a search on the internet with the usual suspects, Stack Overflow and official documentation, and I really could find nothing that helped me to get the information I wanted. So after some exploration, trial and error, I managed to get things straight, and I wanted to share my knowledge about this particular subject, which is, in my opinion, quite important. First of all, what are decorators in Python? Decorators are a category of functions that modifies the behavior of other functions with simple, elegant syntax, which is like this. Add the decorator name before the definition of a function means that each time that function is called, its behavior will be modified by this particular decorator. What's the purpose of decorators? Decorators are very useful for a couple of important reasons, which are basically modularity, don't repeat yourself, and separation of concerns. Let's say I write a decorator to implement a static type check on functions. But I don't want that behavior to be coded inside each function I write. I want to be able to turn it on off, typically to turn it on during development and turn it off before I deploy to production. I can write my functions focusing on what they actually do, that's separation of concerns, and define the modified behavior elsewhere in a module that can be used on a generic module, which can be used on any function I want. And that's modularity. So, decorators are quite a powerful feature in Python, because they allow us to modify the behavior of functions, and they allow for better separation of concerns and modularity in our code. This code includes a couple of examples. Example 1 is to describe the syntax, the usage and the definition of decorators. And example 2 is a practical example, practical real-life example. So let's start with the example 2, where we define a very simple function, this one, which accepts one argument and returns its argument embedded into a string. Correct would be like this. Okay. So I want to do something, let's say I want to do something with the output of this function. So that each time I call this function, its output will not be the original output as defined here, but a modified output as defined in this decorator. How do I implement my decorator? It's quite simple. My decorator will be a function which accepts a function as its input. And inside it will define a function, or we call it a wrapper, which is what actually will be called each time I call my f or any target function. So the wrapper has a set of generic arguments. It calls the target function with the arguments, and it returns its return value embedded into another string with a signature that proves that we are using the modified version with the decorator and not the original one. Note that since the outermost function, the decorator, acts as a lexical closure, it knows about f, which is its argument, and the innermost function, the wrapper, also knows about f from the outer context, from the closure it lives in. So the innermost function, the wrapper, will receive the actual arguments and will know about the function from the closure, so it will be able to call the function with its actual arguments, or do whatever it wants with the arguments and with the return value before calling the function, or calling the function twice or 3 times, or whatever. It's a very powerful tool indeed. So let's disable this decorator. Let's execute the code. I don't see the result. What? Ah, idiot. Sorry. Okay. Again. Result. The original function, which returns my f equals and its parameter 42, which, as you very well know, is the answer to the ultimate question about the life, the universe, and everything. Now let's activate our decorator, run it again, and we see that the result value from the function has become what expected from this decorator. Quite simple, quite powerful, as you see. Things become a bit hairy when we want to modify the behavior of a decorator using parameters. In this case, I want to implement a decorator that runs a function the given number of times and returns a list of the results, or to be more precise, a string embedding such list. Here is the implementation. It's a bit more complicated, but not too much. This is how it works. My decorator is now a function that receives its arguments. Inside, there is a first wrapper, which actually corresponds to the whole decorator in the case of the first decorator we implemented. This first wrapper, the outermost wrapper, receives the function as its argument, and also knows about the decorator parameters from the closure, from the outermost context. And it defines a second wrapper, which is the actual wrapper which calls the function, the target function, and does something with it. Okay. It defines it and returns it. And the decorator returns the outermost wrapper. So there's one more logical step, but it's not too complicated. Let's see what the innermost wrapper does. It receives the actual arguments to the target function as its parameters. It creates an empty list, and in a loop calls the function f. It knows about f because the outer wrapper knows about f. So it calls a function with its actual parameters, and it returns a string that embeds the list of the results. It calls a function, appends the results, to the list of results, and then finally it returns the string. Okay. The outermost wrapper returns the innermost wrapper, and the decorator returns the outermost wrapper. So I want now to activate my second wrapper, which will execute my function twice, and the output of my fn has become the signature of the repeat wrapper and the list, which contains results as modified by the first wrapper. So actually this is a chain. This wrapper calls the function twice, but what it calls is not the original target function, but what it received from the first wrapper, this one. So the chain is the original function, the function is modified by the first wrapper, and the second wrapper received the function as modified by the first decorator, Okay. One last step. We want to modify the documentation of our function with a string. And what we do is we write a decorator with the same pattern. So we have the decorator, which receives its arguments. Then we have the outer wrapper, which receives the function as its argument. And then we have the inner wrapper, which receives the actual arguments, and it's an identity function. It calls the original target functions and returns its value. The outer wrapper, before returning the inner wrapper, modifies its docstring with the decorator parameter, then returns the inner wrapper, and the decorator returns the outer wrapper. So now we activate this wrapper, saying that we want the documentation string for myf to be my function documentation. We also no, let's try this. Before we don't activate documentation wrapper, but before calling myf we print its docstring. So run the code and we see the same result as before from the first two wrappers, and the docstring is known. Then we activate the third wrapper, and the docstring has become my function documentation as expected. So that's how to write chained decorators with or without parameters. As I said, we can use this mechanism for very sophisticated modifications to a function's behavior. A practical example can be, for example, logging functions, and that's what we do in example 2. Example 2, we define two simple target functions, one which returns the constant 42 and one which can possibly raise an exception because it accepts two arguments and returns the ratio without checking whether its second argument is 0. So it can possibly return raise a divide by 0 exception. And we decorate them with a log decorator. Before, let's see the outcome without decorators. So I run both here, and I run the second one, let's say with and without offending arguments. So we see an exception because let's print the output. We see here that the first function returns 42, the second one returns 1 as expected, and the third one does not return anything because an exception has been raised. The zero division error. Okay, so let's implement our logging decorator. It's a decorator that expects a parameter. Note that if a decorator expects parameters, even if you just need the default parameters, you still have to call it with a couple of parentheses. because this means this is the kind of decorator that wants its parameters as its arguments, and not the function, and not the target function. So calling it like this will break my code. So we have our decorator, which expects a log file name as its parameter with a default, and we have an outer wrapper which expects the target function as its argument, opens a log file, and then defines the inner wrapper, and then returns the inner wrapper, and the decorator returns the outer wrapper, as we saw before. So how do we implement the inner wrapper? It receives the actual arguments and it notes about the function from the context. So we take note of the starting time, and in a try block we have an exception flag. We assign the result of the function call to this variable. If we catch an exception, we set the exception flag to true and assign the exception to the result variable. And in the final block we take note of the ending time and we write the log file time start, function call, its module, its name, the arguments, keyword arguments, end time, time elapsed. And if the exception flag is true, we write a somehow visible information block about the exception. Else, we simply write what the function call returned and its type. Important, if we caught an exception, we erase it again. Otherwise, we could disrupt the flow of our code outside the decorator. Okay, so we activate the decorator for the two functions. We delete the function's log file. We run our code. As you see, there is no perceivable difference. We have, just like before, 42, 1.0, and the stack trace for an exception from the offending call. But if we open functions.log, we see we have a call to target fn with no arguments, which returned an integer and its value is 42. We have a non-offending call to target fn except with arguments 1 and 1, which returned 1, a float. And then we have an offending call to target fn except with arguments 1 and 0, which raised an exception of class 0 division error with these arguments. And that's it. As you see, decorators are a very powerful tool for developing software in Python, which allowed for a very sophisticated modification of your function's behavior. in a modular way, with an excellent separation of concerns and with a clean, elegant and understandable syntax. Thank you very much for watching the video. Goodbye.